As an association of complementary companies, the ICI Industrial Cutting Institute brings together manufacturers of machine tools, attachments, cutting fluids, high-speed steel and carbide, and machinist users. Its objective is to further the general knowledge of the industrial cutting sector and through this accumulated knowledge to be instrumental in the business progress of all of its members. The best synergy is achieved through cooperation between members with competitive products who are going to make a commercial breakthrough on their markets by mastering a technological or operational leap forward together. Study of high-speed milling of structural steels. The various machining tests performed within the Industrial Cutting Institute with its partners GIAT Industry, PCI SEM, SOF and UMV Valorb enable an economic and industrial answer to be provided to an ambitious project. Developed for the bulk machining of aluminium aeronautic parts, high-speed machining has asserted itself as an essential part of the process of machining light alloys and metals. Considering the quality of the work, precision, surface condition, residual stress, and of course its productivity, high-speed machining techniques play a leading part in mould finishing and steel press tools. By contrast, the bulk machining of structural steels, still representing 80% of machine materials, cannot be achieved through high-speed machining. The ICI development project focused on the definition of tools and their working environment to allow deep cuts at high feed speeds in structural steels from 650 to 1150 MPa. Business rivalry between two tool manufacturers SOF and UMV Valorb was set aside before the prospects to be derived from the development of such a tool for their market. The completely new design of the tools is intended for the industrialization and standardization of their form and their dimensions. The grooving and orbital drilling operations were carried out on a high-speed machining unit, PCI SEM, of the Meteor 5 type with a power of 25 kW at 15,000 RPM. For orbital drilling, the drill cutter describes a circle and enters the part spirally. The trajectory is also called helical interpolation. In this way, different hole diameters will be made up to twice the diameter of a drill cutter without changing the tool. A H8 diameter on a 24mm diameter will be attained in one single pass. Further to the results given by the test, it therefore appears essential to make an economic and industrial comparison of the machining processes on an actual part. The demonstration part made of engineering alloy steel 42CD4, 850 MPa, comprises different drilling operations, including one calibrated at diameter 24H8 milling and grooving operations for roughing and finishing. The process with the analysis of the operating sequence on a conventional machining center requires the use of 8 different tools. 12 minutes are needed to produce the part. The second test is performed on a high-speed machining center Meteor PCI SEM. One single tool, 12mm in diameter, carries out the whole of the machining operations. The cross-level cooperation between members of the ICI allowed the development of a special single-piece tool, a simple and highly efficient solution as part of the high-speed, rough and finish machining of tools. The use of one single tool producing such results as far as productivity, precision and surface condition are concerned is only possible through the association of this special tool and high-speed machining. The cutting fluid has been eliminated to have a better view of the operations. In high-speed machining, the single cutter replaces the 8 tools of the conventional machining center, carries out the complete machining of the part for the roughing and finishing operations. The part is wholly produced in 3 minutes, achieving a productivity rate 4 times higher than conventional machining. This single cutter is going to do the work of a 24mm diameter one-piece carbide drill, a 23.5mm diameter carbide tip drill, a 20mm diameter carbide tip end mill, a 16mm diameter tip drill, an 18mm diameter drill, a 24mm diameter one-piece carbide reamer, a one-piece carbide end mill, and finally a last cutter for finishing the grooves and obtaining the tolerances. The appearance of the finished part emphasises the quality of high-speed machining compared to conventional machining. The surface conditions obtained at high speed are excellent. The average roughness is less than 0.8, edges are sharp and free from burrs. The rough machining of stills at high speed becomes an industrial reality with substantial reduction of machining time, an increase in productivity, much higher quality results with clearly improved surface and roughness conditions. Furthermore, the limitation of cutting stresses reduces part deformation and the use of a single tool reduces the sizes of machine stores. The whole of the promising results of high-speed rough machining matches the objectives that the ICI set itself through the effective and dynamic partnership between member companies. The information contained in this video is communicated with the permission of the associated manufacturers in accordance with the articles of the Industrial Cutting Institute.